Hello friends, in this video I will show you how you can design a dark sensor. Okay, means the circuit will detect that whether there is light or not. If light is not present, then LED will glow, and if light is present, then in that case LED will not glow. So as you can see on the screen, so for designing this dark sensor, so here I have used one transistor. This is a 2N2222 type transistor. Okay, and one, this is 1N4007 diode I have used, and here I have used LED. Okay, LED here, and one LDR, and this is a 100 kilo ohm resistor. So now first I will explain the working means how this circuit works, and then after I will show you how you can connect different electronic components to design this. So here, so this is 100 kilo ohm resistor, and this is LDR. So LDR also has this LDR, light dependent resistor. This is also a type of resistor. So this transistor will turn on only in the case when this transistor will get sufficient biasing voltage. Okay, if required biasing voltage this transistor gets, then this transistor it is going to turn on. Okay, and if it is going to turn on, then current it will flow through this LED, and if it doesn't turn on, so then current will not flow through this LED. So biasing. So 100 kilo ohm resistor and this LDR, the combination of these two resistor provides sufficient biasing for this transistor. Okay, so when biasing sufficient, then in on state this transistor will turn on this, and the current will flow through this LED, and light it will come, means this LED will glow. Okay, so this working principle of this transistor we will use in this. In the same way I will use, so how the same principle we can apply for turning on and off a motor. Okay, we can turn on any motor or any other devices according to the need. Okay, according to the requirement. For example, here I am using LED, so that's why whatever it is the current which will flow through this LED, so that current that much current this transistor can also hold, because this is not power transistor. Okay, so for high current we will use power transistor, that I will also explain later on. So since low current it flows through this transistor, so that's why this transistor it is sufficient, or so we can use this transistor for this LED. Okay, for making this dark sensor. In another video I will explain how we can use a power transistor to turn on and off means high power electric device or electric machines, how we can turn on and off. Okay, so here, so this is the circuit. So according to this circuit I will show you. Now you can see here, this is a variable power supply. Okay, this is a channel. I will show you how it looks like. Now you can see here, this is a variable power supply. Here two channels are there, first channel here, second channel here. So second channel I am using here in this experiment. So now you can see here, so maximum current which this power supply can give, that is 2 ampere, and the voltage range that is 0 to 30 volt. Okay, so I will show you how the circuit according to the circuit diagram, whatever in the beginning I have explained the circuit diagram, according to that I have made the circuit connection. Okay, so you can see here, here it is one transistor. Here one transistor I have used, this is 2N2222 type transistor. One LDR here, this is LDR. This is 1 and 4007 diode. This is 100 kilo ohm resistor. Okay, and this is LED. This is white LED I am using here, and I will show you how it functions. So as I'm going to turn on this, so now you can see right now this LED, now you can see the voltage you may vary. Okay, I will show you. So just now, right now the voltage I'm taking around 8 volt. Okay, so how much voltage you need? For example, for operating this LED, this is white LED. So according to this, means whatever it is the specification of the LED, means if you use a red LED, then the different voltage you need. So according to that you can change this VCC, means supplied voltage. Okay, so since white LED I am using, so here the supplied voltage you will have to vary, because as compared to red LED, white LED requires different voltage to work on. So now you can see right now this LED is not glowing. Okay, because light is falling on the LDR, and as I'm going to use another mobile to hide. So now you can see I'm going to use my another mobile to. So now you can see this LED will. Now you can see here, as I'm going to hide this. So now you will see that this LED it is glowing. Okay, if I uncover this, so now LED is not glowing, but as I'm going to cover this, so now you can see here LED is glowing. So whether the LED will glow or not, it depends on the light falling on the LDR. If it is falling, now you can see now it will be better. So now here you have the LED. As I am going to cover this, now you can see the LED is glowing right now. As I uncover this, since light is falling on the LDR, so that's why LED is not glowing. It means right now, so as I am covering, it means dark. So now it is dark detector. It is working as dark detector. Okay, it means, so you can see here, as I'm going to cover, so LED will glow, and here uncover, LED will not glow. So in this way this circuit works. And now you can see how much voltage it is coming across this LED. That we can also change. Okay, the voltage across that LED we can also change. So I already told that which circuit component you are using. For example, if you are using red LED, so voltage different voltage will be required, and if you are using white LED, so different voltage will be required. So I will use one multimeter to show the voltage across this LED, and it may vary. Okay, according to the supplied voltage. If you change VCC in the circuit, for example, here you can see in the circuit, if you are going to change in the circuit this VCC's supplied voltage, then the voltage across, now it will be clear. Hold on. Now if you change the supplied voltage VCC, then in that case the voltage across this LED, or the voltage across this 1 and 4007 LED will change. Okay, means variation in VCC will vary the voltage across this diode. Clear? So the same principle we will use in operating different types of machines also. How we can use, means how automatic switch works. For example, automatic stabilizers. The same concept we can apply in so many applications. Principle is here in front of you. Application it depends on you how you can apply. For example, right now I'm using this multimeter to check how much voltage we are getting across this diode. So right now you can see, right now I'm getting here 2 around 2, means around 2.28 we are getting. So the same voltage we can increase. Now you will see that the voltage it will change. How the voltage it will change? Right now, now you can see on the multimeter, you can see how much voltage we are getting. Right now we are getting this much voltage. Okay, so voltage it will vary. Okay, as I'm going to cover this LDR, the voltage across this diode it will change. Okay, so now you can see as I am covering, now you can see the voltage it changed. Now the voltage it came around 2.86. Okay, is if I uncover this, now you can see if I uncover this, now the voltage it dropped. Okay, so this increase or decrease of voltage due to variation in the resistance of this LDR causing this sensor to work. If you have the concept of LDR or transistor and the different circuit component, then in that case you can apply this. Now you can see right now the voltage across this it is around 1.5. So for this white LED we need a voltage around 3 volt. So okay, around 3 volt, around, it may be a little bit less or more than that, but around that. So since it is much less, so that's why this LED is not glowing. So now when I cover this, now you can see the voltage, you can see the voltage on the multimeter, you can see the voltage it reached to 2.83. So 2.83 it is around 3 volt. So that's why this LED is glowing right now. Okay, so when I uncover, the voltage drop. So in this way we can analyze the circuit. We can analyze the circuit. Working principle it is going to remain the same, but analysis it may change according to different situation. Okay, according to different circuits. And the same voltage we can increase or decrease if we change VCC. Okay, for example, I will show you how this same voltage we can increase or decrease by changing VCC. Right now VCC it is around 7.9 the supplied voltage. If I increase the supplied voltage, so now you can see I increase the supplied voltage to around 10 volt. Okay, the supplied voltage I increased to 10 volt. So okay, so now you will see due to that change, okay, in this VCC here circuit parameter will change. I will show you. Again I am going to use the same multimeter, and now I will check the volt. Now you see the voltage level. So right now the voltage it is coming. Okay, hold on. Now what is the voltage coming right now? Now voltage it is coming around 1.96. Okay, and earlier it was coming around 1.5 or something less than that, less than 1.5. But now right now the voltage it increased. Why? Because VCC I increased. As I am going to cover this LDR, now you can see the voltage. So now the voltage it increased. So that VCC may also affect the voltage level across this. Clear? So in this way this dark sensor works, and I will also explain how at the place of this LED we can use relay, electromechanical switch we can use. Here relay is electromechanical switch which we can use to operate any electric machine, just like motor we can operate by using this. Okay, I will show you how we can do. So here you can see, so here not, we don't use here we should not use this 2N22 because since this is not power transistor. Okay, we should not use this. So power transistors are transistor which can handle large amount of current. Okay, so those transistors you have to use which can handle large amount of current. For example, if you are operating 1 HP motor, then in that case the current is around 5 ampere. Okay, 5 ampere current it is required for that 1 HP motor. So if it is 5 ampere, then this transistor cannot work, cannot hold that much amount of current, so it may burn out. So that's why it means power transistor we need. So remaining all things are going to remain the same. The only change it will be that you need a power transistor here at this place. Simply replace this transistor by power transistor, and here you can see at the place of LED one relay you can use, okay, according to the requirement of the machine. So if you are using a high current machine, then in that case you will have to use a relay which can stand to high current also. Okay, so here you can connect, then in that case whenever light it disappear, okay, if we cover the surface of this LDR, then in that case the switch will turn on, and the machine will turn on also. Okay, so in this way this circuit works. So thank you all.